With the growth of the internet, it was clear that a larger address space was needed as long-term solution. The larger address space, however, requires that the length of IP addresses to be increased, which means the format of the IP packets need to be changed. Although the long range solution has already been devised and it is called IPv6, but short term solution was also devised to use the same address space but to change the distributions of the addresses to provide a fair share to each organization. The short term solution still uses IPv4 addresses, but it is called classless addressing. So, to understand the classless addressing completely, watch the video till the end. During the 1990s, Internet Service Providers (ISP) came into prominence. An ISP is an organization that provides the internet access to individuals, small businesses, and mid-sized organizations that do not want to create an internet site and involved in providing internet services such as email services for their employees. An ISP is granted a large range of addresses and then subdivides the addresses in group of 1, 2, 4, 8, 16, and so on, giving a range of addresses to a household or small businesses. The customers are connected via dial-up modem, DSL, or cable modem to the ISP. However, each customer needs some IPv4 addresses. In 1996, the Internet authorities announced a new architecture called classless addressing. In classless addressing, variable length blocks are used that belongs to no classes. We can have a block of one address, two addresses, four addresses, and so on. In classful addressing, the whole address space was divided into five classes. Although each organization was granted one block in class A, B, or C, the size of blocks was predefined. The organizations needed to choose one of the three block sizes. The only block in class D and the only block in class E were reserved for special purpose. In classless addressing, the whole address space is divided into variable length blocks. Theoretically, we can have block of 2 raised to 0, 2 raised to 1, 2 raised to 2, up to 2 raised to 32 addresses. The only restriction is that the number of addresses in a block needs to be a power of 2. In classful addressing, two-level addressing was provided by dividing an address into net ID and host ID. The net ID defines the network. The host ID defines the host in the network. The same idea can be applied in classless addressing. When an organization is granted a block of addresses, the block is actually divided into two parts, the prefix and the suffix. The prefix plays the same role as the net ID. The suffix plays the same role as the host ID. All addresses in the block have the same prefix. Each address has a different suffix. In the classful addressing, the length of the net ID n depends on the class of the address. It can be only 8, 16, or 24. In classless addressing, the length of prefix n depends on the size of the block. It can be 0, 1, 2, 3, all up to 32. In classless addressing, The value of n referred to as a prefix length. The value of 32 minus n is referred to as suffix length. The net ID length in classful addressing or the prefix length in classless addressing play a very important role when we need to extract the informations about block from a given address in the block. However, there is a difference in classful and classless addressing. In classful addressing, the net ID length is inherent in the address. Given an address, we know the class of the address that allows us to find the net ID length 8, 16 or 24. In classless addressing, the prefix length cannot be found if we are given only an address in the block. The given address can belong to a block with any prefix length. In classless addressing, we need to include the prefix length to each address if we need to find the block of the address. In this case, the prefix length n is added to the address separated by a slash. The notation is referred to as slash notation. The slash notation is formally referred to as classless interdomain routing or CIDR notation. Let's take example to understand it clearly. One of the address in the block is 167.199.170.82 slash 27. We can find the number of addresses in the network as well as the first and last address. Here the number of addresses in the network is 2 raised to 32 minus n is equal to 2 raised to 32 minus 27 equal to 2 raised to 5. That means 32 addresses. For first address, we can keep the n leftmost bits of any address in the block and set the 32 minus n bits to zeros. So when we convert the address 167.199.170.82 like this. So when we keep 27 leftmost bits and put 32 minus 27 is equal to 5 bits as 0, we will get first address 167.199.170.64 slash 27. Similarly, to find the last address of the block, we put 32 minus 27 is equal to 5 bits once. We will get last address 167.199.170.95 slash 27. So this is all about classless addressing. Thanks and see you in next video. If you like this video, press like and subscribe the channel and share the video. And don't forget to press the bell icon for my new video notifications. Thanks for watching.